Friends, welcome to Sekho. In this video, I am going to talk about acceleration. Acceleration. So, what is acceleration? Let us say if a particle moves from point P to point Q, then what happens is normally its velocity does not remain constant in this entire path. Okay, when it travels along this path, normally it is seen that its velocity is not constant. You can take any real example, bikes motion, or a car's motion, or whatever, a train's motion. Its velocity is not constant in any path. Okay, it normally changes. So if velocity is changing, then we can define a quantity. Let us say let us say the particle is moving and we want to consider this point and that point. Let us say this is point P1 and this is P2. So at point P1, let us say its velocity is V1, and at time P2 its velocity is V2. So the rate of change of velocity with time is V2 minus V1 by T2 minus T1. Let us say when the particle was in this position, P1 position, when its velocity was V1, then at that point time was T1, and when the particle was at this position P2 and velocity was V2, at this point time was T2. So the rate of change of velocity with time, this quantity is defined as average. This quantity is defined as average acceleration. This is called average acceleration. Okay, so acceleration is actually, if I want to write it in language, in the form of language, we can say that rate of change of velocity with respect to time. So टाइम के रेस्पेक्ट में कितने फास्ट वेलोसिटी चेंज हो रहा है और कितना स्लो वेलोसिटी चेंज हो रहा है, that quantity is called acceleration. This is acceleration. So this quantity, when we take large an extended period of time, this quantity is called average acceleration. But if we reduce this delta t, okay, if we can write this as delta v by delta t. If we reduce delta t, okay, and we make it infinitesimally small, it becomes instantaneous acceleration. Same thing like what we have already defined instantaneous velocity. It's same thing like instantaneous velocity. How we have defined instantaneous velocity, it is almost like same thing. So it becomes limit delta t tends to 0 delta v by delta t, or it can also be written like dt by dt, dv by dt. Okay, it is dv by dt. So this is what acceleration is. Now if you are observing this for the first time, you have to use your imaginative faculties in your brain. Okay, velocity is constantly, velocity may change constant in a constant way. That means rate of change of velocity can be constant, or it can also be changing in the entire path. Okay, so let me take some examples to make it even more clear. Let us say this is a velocity time graph. This is a velocity let me draw a velocity time graph. This is velocity, this is time, and okay, so velocity is in meter per second, time is in second. Let us say that it goes like this, and then it becomes constant, then it falls like that. Okay, so in this case the acceleration from this point to that point, let us say, okay, this is 5, 10, 15, 20, this is 25, this is, let us say, 5, 10, 15, 20, 25, 30, 35, 40, let us say 50. So from 0 time to 15 second, you can see that velocity is increasing. Okay, velocity is increasing up to let us say 25 meter per second. So in this range from 0 to 15 second, you can see that average acceleration is 25 v2. Here v2 is 25 minus 0 by 15 minus 0, so it is 25 by 15, that means 5 by 3 meter per second. You can take any example. From 15 to let us say 35, from 15 to 35 it is constant, from this point to that point it is constant. So from 15 to 35 average acceleration a bar is equal to, here you can see it is 25, so v2 is 25 meter per second, and again v2 is 25 meter per second, v1 is also 25 meter per second, so 25 minus 25 meter per second by time is 35 minus 15 second. So numerator is 0, 0 by something is 0. So here average acceleration is 0 meter per second square. Here it will be second square because this is meter per second and here it is second, so it will be meter per second square. Okay, and from let us say 35 to 50 it is reducing like that, following an straight line, so it is reducing, so this is actually negative acceleration. So let us calculate average acceleration. A equal to final velocity here is 0, v2 is 0 minus initial velocity is 25 and the time is from 35 to 50, so t2 is 50 minus t1 is 35, so it is minus 25 by 5, 15, so it is minus 5 by 3 meter per second square. Okay, so this is how we can calculate average acceleration from these velocity time graph, and in the similar fashion like what we have done in case of instantaneous speed, we can also define instantaneous acceleration. Okay, it will be just the slope of the tangent of velocity time, slope of the tangent of the velocity time graph. Okay, it will be instantaneous acceleration. Now let us see see a relation. Acceleration, average acceleration is v2 minus v1 by t2 minus t1. Now if we consider t1 equal to 0, that means it's started from the 0 time, that means when we started to observe the phenomena the particle's motion, we call this that time is 0, and let us write v1 is equal to v0. So what we get is average acceleration is equal to v minus, let us say this is v2 minus v0 by t2 minus t0. Here t0 means 0, so we can find from this v2 equal to at plus v0 or v0 plus at. What it means is final velocity is equal to initial velocity plus acceleration, average acceleration into time. Now if the acceleration of the particle is constant, in case of constant acceleration, any instantaneous acceleration and average acceleration will be same. Okay, so we just can write here a v0 plus at. Okay, so this is a formula, and also this formula sometimes is written in many textbook, like v equal to u plus at or u plus ft, like that, where a is acceleration, constant acceleration, f is acceleration, u is initial velocity. Okay, so this formula is used in many simple problems. You have to understand it and remember it. Okay, it comes just from the definition of average acceleration. Okay, in case of constant acceleration, average acceleration and constant acceleration becomes same thing. Instantaneous acceleration, you may call it instantaneous acceleration, average acceleration, or just acceleration. It means same thing in case of constant acceleration. Okay, now we are going to see three graphs, and we are going to guess what kind of acceleration it is. The position time graph, this is position in meter, let us say it time in second, and position time graph goes like this. Okay, so what happens here, you can see that when time was 0, let us say this is x-axis, when time was 0, it was, let us say this is origin, this is x, positive x-axis. When time was 0, it was some distance away from the origin, it was some distance away from the origin. Then its x value is reducing as time is increasing. That means it is returning towards, it is coming towards this origin. Okay, it is coming towards this origin, but what happens is finally its velocity is becoming 0 at this point. Why? Because velocity is the tangent, slope of the tangent. Here the slope of this tangent at this point will be 0 because it is parallel to x-axis. Okay, so here velocity becomes 0. That means particle was moving towards this direction, but its acceleration was, motion was, v was in this direction, but a acceleration was in that direction. That means particle's velocity was decreasing as it was moving towards origin. It was moving towards origin and its velocity was decreasing, and at some point it has become 0 and it started to return back again in this direction. Okay, and the rate of change of that velocity was constant throughout, maybe constant, but its acceleration was positive in this direction. Okay, so this is positive acceleration, a is positive. So after becoming velocity becoming 0, it is again, x is again started to increase. Okay, so this situation is here we can see this graph represents this situation. Now we draw another position time graph. let us use a different color. This is position, this is time, position in meter and time in second, and let us say the position time graph is like this. It is carved in the like this. Okay, so in this case what happens is, it was, let us say this is origin, this is x-axis. It was at certain time, it has initial velocity, initial position little further away from x. Okay, then its position, its value of position, that means it moved in the positive x direction, so its x value increased, and then finally its velocity became 0, so it started to return back again in this direction. So in this case we can say that acceleration is in the negative x direction. Okay, negative x direction. So what happens, it moves in the forward direction, in the positive x direction, but acceleration is in the negative x direction, so its velocity is reducing, and finally it becomes 0. Then it starts to return towards origin, so again its x value starts to reduce. So this is what this situation can be represented by this graph. Now we have another position time graph. I'll use another color. Okay, let us say this is x and this is t, x meter, and this is t second, and the position time graph is like this. So here you can see that position is increasing. Okay, position is increasing as time is increasing. So, and rate at which the position is increasing is constant. Rate is constant, that means here velocity is constant, isn't it? Here this graph represents constant velocity, constant velocity. So in this case acceleration is 0. I hope you understood this, because it is not curved in upward direction or downward direction. That's why it is not, it's actually it is not accelerated. That's why it is not curved in the upward direction or in the downward direction. Okay, so this represents the situation where the acceleration is 0. That means the particle was moving towards positive x direction and its velocity is constant, it is not changing. Okay, it is moving with constant velocity. So these are the three things I wanted to discuss here, and then we have some more graphs here to discuss. Let us take this example. This is velocity time graph. Velocity time graph. Let us say this is v0. Okay, and it is some v. So if you look at this graph, you can see that velocity is increasing and its rate is constant. It is increasing with constant rate. Why? Because you take any position, you will see that rate means this change of velocity by change of time will be constant at any position. Take any position, you will get that. Okay, so rate of change of velocity is constant. So this, in this case, acceleration is constant acceleration. So and it is positive, acceleration is positive because velocity is constantly increasing. let us take another example. Let us take V versus T graph. V versus T graph. Here graph is like this. Okay, here you can see that velocity is decreasing with constant rate, isn't it? So this is acceleration is constant, but it is negative. Acceleration is negative. And then we have another example. Let us draw on more. Let us say this is origin, this is time axis, and position time graph. This is velocity time graph is like this. Initial velocity was minus v0 and it is constantly increasing in the negative direction, you can say. Okay, that means its velocity was in the negative x direction, and that velocity is constantly increasing in the negative direction. So this is constant negative acceleration. In that case velocity was positive initially. Okay, particle was moving in the positive x direction, but its acceleration was in the negative direction. In this case the acceleration is in the negative direction, and also the particle is moving in the negative x direction. Okay, so then let us draw on more graph. This is velocity time graph. Let us draw like this. This is velocity along this time. Okay, and the graph goes like this. Okay, what happens in this case? Initially the particle was moving with positive velocity. Its velocity is positive, isn't it? But it is reducing. That means it is moving in the positive direction, positive x direction, but velocity is reducing with constant rate. So it is reducing with constant rate, and finally it is becoming zero here. So velocity is becoming zero here. That means particle was moving in direction, moving in this direction, but its velocity is reducing, and finally velocity is becoming zero somewhere. Then it starts to move in the negative x direction. That means it initially it was moving in the positive x direction, and then finally it moves in the negative x direction, and in all these all the things that is happening, the acceleration was constant and it was in the negative x direction. It was negative. Okay, so I hope that you understood all these graphs. If you have any problem, I am here to answer your doubts. I will demolish your doubts. Okay, now let us see one more thing, then I will stop here. Okay, I will not make very much big video, otherwise you will not have your patience to follow. Okay, so let me take this color. I will draw V versus T graph. Okay, V versus T graph. Let us say particle is moving with a constant velocity v. So v is not changing along this time. Let us say in second. This is meter per second, and it is moving with constant velocity. That means time is changing, but velocity is remaining that much. it is not changing, it is that much only. Okay, so what is the distance it travels after time t? If we call this is time t, how much distance it has traveled? What we do, velocity into time is the distance it travels. If velocity is constant and it moves t time, then the distance traveled is vt. S is distance is v into t, and graphically you can see that this much is v, this much is v, this much is v, and this much is t. So if we multiply v into t, it becomes the area of this rectangle, isn't it? Area of this rectangle. So S becomes area of the rectangle of the velocity time graph. Velocity time graph. And this is not only true for constant velocity, this is true for any kind of velocity. Okay, and you will see this when you will learn about calculus little more, integral calculus. You will realize this little better, and maybe I will discuss this in the next videos if I see that I have scope to discuss that in this chapter. Okay, so guys, this much for this video. I'll see you soon in the next video. If you guys think that I am making great videos, or in future I'll make much greater videos for you, and these videos will be helpful for some students of class 11th, class 12th, or maybe for some other students who thinks that they need to understand basics. Maybe they are currently now in graduation or MSc, but you feel that you should revise your basics, then it can be useful for you also. Okay, so in that case, if you think these videos are valuable, then please hit the like button and also subscribe this channel. इस चैनल को सब्सक्राइब कर लेना दोस्तों, क्योंकि मेरा जो यहाँ पे मोटो है प्योर फिजिक्स डिस्कस करना है। यहाँ पे कोई स्टोरी, कोई कुछ डालने का मेरा कोई टेंडेंसी नहीं है। यहाँ पे प्योर फिजिक्स मतलब स्टोरी रहता है फिजिक्स में, बट that should be relevant. Sometimes people just make some kind of stories, irrelevant stories, and somehow it somehow it matches with the formulas, and somehow it helps to remember formulas. And so you remember formulas, and then you apply those formulas and you solve problems, and you get good marks and so on, and finally you feel ultimately boring. Physics becomes difficult or boring when you go to higher studies. Okay, because you have weakness in the fundamentals or basics. So my motto is to clear basics. Okay, I'll discuss every basics, and I'll clear every basics. I'll demolish all the doubts, and if there is any genuine doubt in the basics, then I will, genuine doubts means it is doubtful to me also, or maybe it is not clearly understood by physicists, or it is not clearly discussed in popular books or available books that I have read so far, then I will clearly mention it to you that this is the point which is doubtful. There is no notanki, no hiding. Okay, I will not hide anything. I will open your eyes. If I cannot explain the object, what is it, then I will just show you the object. I will open your eyes and I will show you the object to see by yourself. Now if you can explain it by yourself, it's okay. If you cannot explain it, you will just realize that it is not explainable very easily, okay. But I will open your eyes and I'll show you the object, okay. There will be no ghaplabaji. So if you guys, okay, I have given a very big lecture, so I will stop here. I'll see you soon in the next video. Thank you for watching.